Hello and welcome. Today we're going to be talking about extension 12.3, which is angle measures of triangles. This does come after section 12.3 in your textbook, which we have not done yet, but we're going to go ahead and do them in a different order. So the key idea for today is that the sum of the angle measures of a triangle is 180 degrees. That means that if you take all three of the angles and add them up, you will get a total of 180. So in this picture, one of my angles is x, another is y, and the last angle is z. To the left, algebraically, if I take x, y, and z and add them up, I will get a total of 180 degrees. In example 1, part A, my three angles are x, 28, and 50 degrees. If I add those up, x plus 28 plus 50, I am going to get a total of 180 degrees. So I can write my equation like this. The directions ask us to find the value of x, so now I'm going to proceed to solve. When I combine like terms, I end up with x plus 78 is equal to 180. And then, of course, subtracting 78 from both sides, I will get x is equal to 102. And like we talked about before, we don't need to put the degrees symbol on there because if we go plug x back in, the degrees symbol will already follow. In part B, I'm going to do the same thing except with different angles. I have three angles and I know that for a triangle, the three measures of the angles add up to 180 degrees. So if I start with x, I'm going to add 45. And then I have a third angle that's not listed with a numerical degree, but it does have this symbol here, which means 90 degrees. So x plus 45 plus that third 90-degree angle is going to add up to 180 degrees. And from here now, we can combine like terms and solve. X plus, this gives me 135, is equal to 180. And subtract your 135 from both sides, you will find that x is equal to 45. So here my angle is 45 degrees. Now if you look, this is an isosceles triangle, which means two of the sides are the same. These little dashes means that those two sides are congruent or the same. Well, one property that we have about isosceles triangles is that the angles opposite those sides are the same. So you'll notice we started with a 45 here, and the other angle also ended up as 45. And that is because this is an isosceles triangle where those two sides are the same. Slide number 2, I'd like for you to go ahead and practice these 6 on your own with your table. So you can go ahead and pause the video and work on these for a few minutes with your group. For number 1, I got x is 91. Number 2, x is 75. Number 3, x is 90. Number 4, x is 94. Number 5, x is 48, and you might have been able to do this without even writing an equation, because if you notice, we do have an isosceles triangle. These two little red marks mean that those two sides are the same, so that means the opposite angles have to be the same as well. So x and 48 have to be the same. Or you could have written the equation like I did down here. Lastly, you might use the same strategy. If you notice that this is an equilateral triangle, that means all the angles are actually the same. But if you go through and write an equation to solve it, you will find that x is equal to 60 degrees. On the next slide, we're going to tell whether the triangle can have the given angle measures. If not, we're going to fix the first angle so that the angle measures form a triangle. So all we're going to ask is, do the angles add up to 180 degrees? So our question, do they have a sum of 180? And if not, then we're going to change the first one so that they do. In number 7, I've got 76.2. I'm going to add the 81.7. I get 0.9, 6 plus 1 is 7, 7 plus 8 is 15. And now I'm going to add this third one, which is 22.1. I'm hoping they add up to 180. 9 plus 1 is 10, carry my 1. 7, 8, 9, 10. Here's my decimal. 5, 6, 7, 8, and 1. Since we added and we got a sum of 180 degrees, the angles do form a triangle. Number 8, we're going to do the same thing, just different numbers. I'm going to start with 115.1. I'm going to add 47.5. When I add, I get 6. There's my decimal. 7 plus 5 is 12. Carry my 1. 4, 5, 6, and 1. Now I need to add on that third angle of 93. You might be able to see that this is not going to work out. Line up your decimals. 6 plus 0 is 6. Here's my decimal. 2 plus 3 is 5. 9 plus 6 is 15. Carry my 1 to get 255.6. That tells us that this first angle, 115.1, needs to be changed. So I am going to go ahead and call that x. I don't know what it needs to be, but I do know that when I add it to the other two, I need to find a total sum of 180 degrees. So I'll write this equation and then go ahead and figure out what x needs to be. When I combine like terms, I get 140.5. So now my new equation is x plus 140.5 is equal to 180 degrees. And now I solve by subtracting that 140.5 from both sides of my equation. And x is going to be equal to 39.5. So in order for these three angles to make a triangle, I need to change this first angle to 39.5 degrees. I'd like for you to go ahead and pause the video and try the next two on your own. For number 9, this is what I got. I started by adding the first two. These first two numbers added up to 70. But then when I added on my 87, I got a total of 157, which is not enough. So that first angle is too small. So I went back and I changed that first angle to x to figure out what it needs to be, and then wrote my equation down below. X plus 64 1/3 plus 87 is equal to 180. When I add these two, I end up with 151 1/3 is equal to 180. If you don't like working with mixed numbers, as you know I do not, you may change it to an improper fraction. Either way, when you're done, you should end up with your new angle being 28 2/3, or as an improper fraction, 86/3. When I tested number 10, I did find that all three of those angles added up to 180 degrees. When I added the first two, I got 85 1/4, and then adding on that third angle down here, I ended up with a total of 180. So therefore, the angles do form a triangle. On our last slide, we're going to go ahead and find the value of each of the variables. In letter A on example 2, we've got two missing angles, but notice they are the same thing. The first reason we know they're the same is because they're both labeled the same. And the second reason we know they're the same is because this green triangle is isosceles. When we look at those two red marks, we do see that those two sides are the same, which means the angles have to be as well. So x plus that third angle of 128 has got to be our 180, or 2x plus 128 is going to be 180. Subtracting your 128 from both sides, you will get 2x is equal to 52. And when we divide by x on both sides, we find that x is going to equal 26. And of course, you can go back and check this by plugging everything in. When you put a 26 here for x and here for this x, those three numbers should add up to 128 degrees. Letter B, very similar. I've got x and x, they are the same, and I'm going to add them to this 60, so I find out that x plus 60 has got to be our total of 180. So 2x plus 60 is equal to 180. Subtracting our 60 from both sides, I find that 2x is going to equal 120. And when I divide by 2 on both sides, I find that x is equal to 60. This did come up on a previous slide. This 60 degrees and this 60 degrees, along with the third 60 degrees, tell us that all three angles are the same, which does mean that the triangle's three sides are the same. So this is an equilateral triangle. Go ahead and take a moment to pause the video and do numbers 11, 12, and 13 on your own or with your table. For number 11, I got that x has to be 67.5. For number 12, I found that x equals 60, which remember, if all three sides are the same, then all three angles are the same. So if one of them is 60, so are the other two. And lastly, this is an isosceles triangle where x is equal to 24. Now to go back and classify each of the triangles, we did not do that quite yet. Example 2, letter A, first thing I'm going to do is look at the angles. I notice that one of them is larger than 90, so this is obtuse. If any sides are the same, then it's going to be either isosceles or equilateral. Since only two sides are the same, this is an isosceles triangle. For letter B, all of my angles are 60 degrees, which means they're all less than 90, so it is acute. But more than that, if all three angles are the same, so are all three sides. So this is not only an equilateral triangle, because all three sides are the same, but it's what we call equiangular, since all three angles are the same. Number 11, my x value is 67.5, which means two of the angles are less than 90. This 45 is also less than 90. So all three angles are less than 90, making this acute. And since two of the sides are the same when we look at these markings, it is an isosceles triangle. Number 12 is just like letter 2B. This is an equilateral equiangular triangle. And number 13, I've got two angles that are the same, and so are these two sides, which makes it isosceles. Since one of the angles is bigger than 90, it is obtuse. So this is an obtuse isosceles triangle. Thanks so much for watching. I hope you guys have a great rest of your day. Make sure to take a moment to write down your homework in your planner, and it is also on your stamp sheet. I'll see you all tomorrow.